Hello everyone, I'm Greg Weaver. Welcome to the Audio Analyst. Pardon me. Before we get into today's discussion, I want to thank all my current subscribers and remind new viewers that if you are enjoying these conversations, if you find any merit or value in the information I'm sharing here, please be sure to subscribe, like, and to share links to your favorite episodes with your friends. And please leave your comments and questions. I love hearing from you. And should you wish to take a more active role in supporting the channel, and in the process receive exclusive access and content, I hope you will consider becoming a patron. You'll find a wide range of Patreon subscription levels available to meet any budget or level of generosity. And if a one-time donation makes more sense for you using Patreon, PayPal, or Venmo, I provided the necessary information in the comments section. Please know that your support at any level ensures the continued production of these conversations and is most sincerely appreciated. Now, while I suspect that you have heard the terms Biwire and Biamplify, I'd also wager that you probably don't know exactly what they mean, how to implement them correctly, or understand their potential significance. The use of either will afford you a clearer, purer, and more articulate view into your music. Now, sadly, not every pair of loudspeakers may be able to realize these benefits. If your speakers have two pair of speaker input binding posts, and some speakers may actually have as many as three, then you're ready to take advantage of something that the manufacturer of your loudspeakers clearly hoped you would leverage. If your speakers have two sets of binding posts, when you first got them, the common colored posts of both sets of inputs would have been strapped together by a jumper of some nature. Now, those jumpers are provided by the manufacturer to link the speaker's internal crossover networks, since not everyone will choose to Bywire or Biamplify. The provided jumpers are necessary to connect both the low and high frequency section of your loudspeaker's crossover in case you do only use a single wire set. But they are deliberately separated into two sets of inputs to allow for the advantages Bywiring or Biamplification will afford. And you will likely have noted that those provided jumpers are usually pretty low quality, sonically speaking. Typically, they are made of tin, zinc, or something not copper, and they may be chrome or gold plated to help prevent oxidation. But they are only offered as convenience. I don't think any manufacturer would hope that you would actually use them. If you do not choose to Bywire or Biamplify, please be sure to invest in some high-grade jumpers from a well-regarded cable manufacturer. Don't use those metal throwaways. They're junk. Now, the term Bywire refers to the fact that you'll be running two sets of loudspeaker cables, 4 pair, by wires, from your amplifier to each of your loudspeakers instead of just one single wire set. Now, I recommend that your second set be of the same brand and series as the ones you use now, but you may try something different if you don't have two identical pairs. More on that later, but they should also be of identical length as well. Now, some cable manufacturers make what are called shotgun Bywires. These are pre-built cable sets with the two ends that connect to the amplifier already tied together with one termination. Now, using such cables will simplify installation, but as convenient as they are not necessary. And since not all manufacturers offer them, we'll cover the more common application of using two separate single cable sets. Go to the back of your speakers and remove the strap or jumper connecting the two sets of posts on your loudspeakers. These dual posts are usually located one pair above the other, but there are some other less likely configurations, such as these from my older Celestion 100 monitors. If you are unsure exactly how to remove them, refer to your product manual or check with your dealer or the manufacturer. But for most speakers, removing those connections will be obvious. Now, once unstrapped, the posts allow separate paths to the individual crossovers for each driver or group of drivers. Now, head to the back of your amplifier or receiver. If it is equipped with traditional 5-way binding posts, the next step should pose no significant problem. Many of today's amplifiers include dual output posts for just such purposes, while others, and most older amplifiers and receivers, offer several switchable and selectable speaker outputs, normally labeled A and B. With those amplifiers, connect one set of the speaker cables to each set of outputs from the amplifier. Then be sure to switch on both sets of the outputs from the speaker selector switch, typically on the front of your receiver or amplifier. Now, most speaker cables today are terminated with spade connections at both ends. If both of your chosen loudspeaker cables use the banana type connections on the amplifier's end, or if your amplifier or receiver uses those push spring clip type of connections, you'll have to use a receiver or amplifier that has more than just one pair of speaker outputs. Now, if you have one pair of cables terminated with spades and a second pair terminated with bananas, both will easily fit into the traditional 5-way binding posts and make installation that much simpler. When using a single set of output posts on your amplifier, we will need to connect two pair of speaker cables to each set of corresponding output terminals on the back of the amp for each channel. Now, this means that both ends of the pair of positive cables that will go to the right speaker will be connected to the single positive terminal of the right amplifier output, and that both ends of the pair of negative cables that will go to the right speaker will be connected to the single negative terminal of the right amplifier output. Do the same with the left channel, with the other two sets of loudspeaker cables, and we're ready for the next step. Now, run each doubled wire set to the back of their respective loudspeaker. Attach one pair to the high frequency terminals and the other set to the low frequency input terminals of each speaker. Now, power everything up and enjoy the fruits of your efforts. There should be more clarity and detail to the mid-range and high frequencies. Often, low frequencies are less bloated, becoming both a bit faster and tighter. Not always, but it happens. Focus and staging should improve nicely as well. You will likely notice less congestion in dynamic or complex passages, and microdynamic expression will be improved. In all, this is a very effective and desirable improvement, and only requires the investment in a second set of speaker cables. Now, biwiring works by greatly lessening, if not completely eliminating, the backward flow of energy induced by physical woofer travel. Backward EMF, or electromotive force, is a reactive force. In this instance, we are talking about the voltage generated by the woofer as it settles to a stop after being driven into play by a powerful bass note. Too massive to just stop instantly. As it settles, it cycles forward and backward until it comes to rest. But during this motion, as its voice coil is traveling through the magnetic field of its motor, it induces or generates its own voltage, which is sent backward through the woofer's connecting wires into the crossover. Now, With a single set of speaker wires, that induced woofer signal is reintroduced into the crossover network, where it will have a corrupting and damaging impact on the lower level and delicate mid-range and treble components of the audio signal. With biwiring, it is effectively and all but completely isolated from the mid-range treble circuit. When biwiring, we are altering the return path for these powerful induced bass voltages. With single wiring and jumpers, that signal is injected back into the loudspeaker's crossover, where it can overwhelm and greatly degrade and pervert the integrity of the much lower energy components of both the more fragile mid-range and treble information. With biwiring, the backward electromotive force induced by the woofer is seen and managed at the amplifier outputs rather than at the loudspeaker's crossover. As most of today's well-designed amplifiers have very low output impedance, this induced EMF signal will have little to no effect on the amplifier. Amplifiers express this relationship as a damping factor, the ratio of the amplifier's output impedance to the driver's voice coil input impedance. The larger the number, the better. Now, for example, my AudioNet Maxes have a damping factor greater than 10,000 at 100 Hertz. For reference, in the mid-1980s, even with highly regarded amplifiers like the overachieving Nelson Pass-designed Adcom GFA 555, damping factors of 150 to 200 were considered excellent. Now, I said we'd talk about the use of different loudspeaker cables, assuming that you couldn't have two identical sets. I'm not a big fan of the seasoning to taste approach using cables, but if you must, biwiring permits you to select specific wires for each frequency application. If you have been at this hobby for any length of time, you will have heard that all wires, both loudspeaker and interconnects, possess their own characteristic sound. When biwiring, you may match a wire that is open and airy, but is perhaps a little lean or thick in the bass region, to the high-frequency input. The same can be said for using cables to connect the low-frequency drivers, because I strongly recommend using identical cables in identical lengths for both runs. Taking the next step, moving to passive biamplification, affords even greater advantages. Here, you will use two separate amplifiers and two pair of interconnects to connect the preamp outputs to each of those two amplifiers. Further, there are two types of biamplification configurations. In the standard configuration, referred to as horizontal biamping, one amplifier plays the low frequencies for both loudspeakers, while the other reproduces their high frequencies. Now, as with biwiring, in horizontal biamplification, you may use two different amplifiers, but you'll want to try to match their output and impedance characteristics as closely as possible. And once again, I really recommend using identical amplifiers when possible. The second biamplification configuration, called vertical biamping, requires the use of identical amplifiers. In this case, one amp drives the entire right speaker, while the other drives the entire left one. Here, one channel of each amplifier handles the low frequencies, while the other channel of that same amplifier handles the high frequencies. I most recently reviewed the Constellation Inspiration 1.0 stereo amplifiers in this configuration with wonderful results. The vertical configuration also has a distinct advantage over the horizontal configuration. Crosstalk, the tendency for one channel to bleed through to the other and thereby cause distortion, has effectively been eliminated. Both channels of each amplifier are being fed identical information. So even if there is any kind of spurious leakage between the left and right channels of the amplifier, Because it is the same signal, it cannot create harmonic or intermodulation distortion. Whatever pair of amps you select, and whichever configuration you choose, you must be able to get the preamplifier output of both left and right channels to both amplifiers. Now, if you're lucky enough to have a preamplifier with 2 sets of outputs, you're home free. If not, this is most easily accomplished with the use of Y adapters. In this case, consisting of one male RCA or XLR jack that is terminated to 2 female RCA or XLR plugs. Because you must be selective when choosing these Y adapters. The least expensive versions available from Best Buy or at a department or home building supply store are certain to degrade the overall performance of your system, more than enough to negate the advantages you hope to gain by biamplifying in the first place. So select high-quality, well-terminated Y adapters. Inserting them into your preamplifier's left and right output will provide you the necessary dual outputs needed for each channel. But your preamp will also see the 2 amplifiers' impedance in parallel, which effectively halves each amplifier's input impedance. Now, in the horizontal configuration, the speaker outputs from the amplifier chosen for the highs are then connected to the respective high-frequency terminals of both speakers. That is, the left output from this amp feeds the left speaker's high-frequency input terminals, while the right output from the same amplifier feeds the right speaker's high-frequency input terminals. Duplicate these connections from the other amplifier to both speakers' low-frequency inputs, and you're ready to go. With the vertical configuration, each amplifier will still receive 2 channels of information from the preamp, but they will both be the same. The amplifier dedicated to the left speaker will now receive only left channel outputs from the preamplifier to feed both its right and left channel input. The second amplifier, dedicated exclusively to the right speaker, will then receive only the right channel outputs from the preamplifier for both its left and right input. Now, this can be achieved in the same manner as used in the standard horizontal configuration, but by simply changing how the 2 patch cables are connected to the separate preamp or the Y adapter's output at the back of the preamp. Now, another option for the vertical configuration is to use different Y adapters. You may use a set of Ys at the amp, but of opposite configuration. In this case, 2 male ends with 1 female end. Plugging the 2 male ends into both the right and left input will allow for a single left and right preamp output to drive each left or right amplifier. You then use each amplifier here to run its own speaker rather than having the high frequencies driven by one amp and the low frequencies driven by the other. You would, for example, use the left output of the left amp to drive the left speaker's high frequencies and the right channel of the left amp to drive the left speaker's low frequencies, with the right side being a mirror image of the left. Now, no, it is not necessary to use the left channel for the highs and the right for the lows, as both channels carry the same information in this configuration. I simply chose that to be able to describe the connection methods. Now, the advantages to biamping are identical to those of the simpler biwired approach, with added benefits. Since you have probably doubled the power you were using with just 1 amp when biwiring, you will realize elevated clarity, detail, and resolution, as well as seeing the benefits of the increased power, which will aid in areas such as dynamic contrasts, individual voicing of instruments, and perhaps with deep bass performance. Guys, I suggest you give these a try if you have the opportunity. Just adding that second set of speaker cables can uncover tremendous clarity and increase the focus, staging, and imaging in even the most modest of systems. If you happen to be fortunate enough to have a second amplifier lying around, or can afford to add a second, give one of the Biamplification setups a try. I highly recommend the vertical configuration. Either way, you will have taken yet another step closer to musical nirvana. As always, thank you for taking the time to drop by and visit today. Remember to subscribe and to like and share your favorite episodes, as well as to post your comments and questions. Please stay safe in this most unusual of times and keep the music playing. Till next week, cheers.